Hello, my name is Sunil Agarwal. I'm a Principal Program Manager with SQL Server team. Today, I'm going to talk to you about a new exciting technology, real-time operational analytics, that is coming out in SQL Server 2016. So what exactly is real-time operational analytics and why do we need it? I want to showcase that with a simple example. Imagine you are running a departmental store where you have large number of transactions. You are selling perishable goods, you're selling regular goods. So what you do is you are running your OLTP transactional workload for your departmental store. Transactions are coming in. And what you want to do is, if there are perishable items and if they are reaching the expiry date, you want to provide a incentive to the buyers to buy them because you want to sell them before the expiry date comes. And typically what customers do, they take the transactional data and they ETL the data into a dedicated data warehouse, which I'm showing you here on the right side. And for here, I've chosen SQL Server as data warehouse. And now, once you have the data, you want to do analytics on it. And what I'm showing here is a query which you are running on your data warehouse. And for example, you are finding out what are the perishable items, when are they expiring, what is the quantity on hand. And based on that information, you want to offer discounts to your customers. You can do this analytics directly on SQL Server, or you can run it through a analysis server. But the key thing is you are doing analytics on your transactional data to provide promotions to your customers. Now, this solution works. People have been using this kind of framework for many, many years. But what we are finding is today, businesses want analytics to be done on the real data. And the rationale is simple. They want to be able to act to the transactions and act on it with respect to analytics in a very fast way. The challenges with this approach are, number one, it is a complex implementation. You have to implement ETL. You have to create data warehouse, bring the data in, and set up the analysis services. So it's a complex implementation. Besides complexity, it is also expensive. You need extra license for setting up the data warehouse. You need to create ETL application, and you have to manage a lot more servers to make this application work. Even if the business can handle that, the key challenge with this one is that your analytics is behind time. Businesses want to do the analytics in real time on the operational data. So this is a challenge that is solved with SQL Server 2016. So let's take the same application like before. You are running your departmental store with the transactions. And with SQL Server 2016, all you need to do is to create a column store index on your transactional tables that are needed for analytics. And now with column store, you can continue to do your transactions like before, and the column store can give you a superior query performance for your analytics. So all you need to do is now you can query directly on your transactional systems, or you can even use analysis services. So from the analytics perspective, nothing has changed. You continue to do your analytics, but you're doing that analytics on the transactional system on the same table where you're running at OLTP transactions. So the ability to do analytics on your transactional system in real time is what we term as real-time operational analytics. Now, the key benefits of this technology are, number one, there is no data latency. You can do analytics in real time on your transactional system, and this is what business want. And the side benefits are, there is no ETL. You don't have to worry about how data moves from the transactional system to your data warehouse because you are running analytics on the same data that is in the transactional system. And finally, there is no separate data warehouse. That means you're reducing your cost in terms of licensing, setting up a new server. But there are challenges. The challenges are, how do you run this real-time operational analytics without impacting your transactional workload, because they will take cycles? And how do you do a performant analytics on this data? And let me show you how SQL Server 2016 achieves that, both for traditional tables, which is disk-based tables, as well as for in-memory, memory-optimized tables. So what you see here is a simple disk-based table with one or more non-cluster indexes. In a typical transactional application, you will have many of these tables, say hundreds of tables or even thousands, and you may want to do analytics only in a subset of those tables. So once you have identified those tables, all you have to do is create a updatable non-cluster column store index on that table. It's like any other index. Now your transactional workload will continue to work like before. And for any queries that is doing analytics, SQL Server 2016 will automatically choose the non-clustered index to give you very efficient execution of your analytics workload. Now, question comes, how do you minimize the impact on the transactional workload? And SQL Server 2016 offers few options for you to control that. If you look at the delta store, which is sitting on the right side of the non-cluster column store index, delta store actually is a part of non-cluster column store index. Any operations that are done recently, for example, inserts, updates, deletes, they are done on this delta store. And operations done in the delta store are much more efficient than if those operations were done in the compressed store. So in SQL Server 2016, you can control how long the data stays in the delta store. By doing that, you're minimizing the impact on the OLTP workload. There's another option available. So for example, if you know when data becomes cold, I'll give you an example. For example, you have a order entry system and you place an order, and order goes through some changes, and ultimately the order is shipped. So when the order is shipped, it becomes cold because it won't see too many changes. So what you could do is you could create a filter index, the filter non-cluster column store index. By doing that, you are keeping the data that is hot, that is the order that is in transition, and there is no non-cluster column store index. It is sitting only in the row store, and your transactional workload is not paying any overhead of the non-cluster column store index. By doing that, you are minimizing the impact on the OLTP workload. And the interesting thing is, when you do your analytics, SQL Server 2016 picks up the data not only from the non-cluster column store index, it also picks up the data from the row store. So it is completely transparent to the analytics queries where the data is coming from. And what you will see is real-time operation analytics that combines both the column store and the row store to give you the analytics that you're looking for. So that's the key benefit that you see with the non-cluster column store index on your traditional systems. Okay. Now let's take a look at how we have integrated the same technology in the memory optimized tables. In SQL Server 2014, we came out with this technology that could speed up the OLTP workload up to 30x. And we combined that with the column store technology, which could give the analytics up to 100x faster. And in SQL Server 2016, we have combined the in-memory OLTP with the column store technology to give you a combination of both in-memory OLTP as well as in-memory analytics. And this combination can be used to deliver very high transactional performance and at the same time, very high analytics performance. And SQL Server is the first commercial vendor that has combined these technologies in a native way to deliver real-time operational analytics at a very high performance. So real-time operational analytics with memory optimized table is done in a very similar way, the way we did that for the disk-based tables. So what I'm showing here is a database for transactional workload, which has one or more memory optimized tables. And this is one example of a memory optimized table. And what you see here is a hash index and few range indexes that you need for your transactional workload. Just like what we did for disk-based tables, to do real-time analytics on this table, all you need to do is create a column store index. As soon as you do that, your transactional workload continues to work like before, And SQL Server 2016 will automatically route your analytics queries through the column store. Now, if once you have created the index and now you're inserting more rows because transactional workloads will add more rows, update more rows, those rows land on the memory optimized table in the area that I'm showing as a hot area. Now, any transactions that are touching the hot data are not really paying any overhead for column store because there is no column store on the hot data. And once this hot data reaches a threshold, we have a threshold of million rows, SQL Server automatically compresses this data into column store. Now, if for your workload, you know the data stays hot for 2 hours or 3 hours, you have an option with SQL Server 2016 to control how long you want to keep the data into the hot portion. So by using that option, you can keep data longer in your hot portion. By doing that, you're minimizing the impact of column store on your transactional workload. And just like before, your analytics workload, when you run the query, SQL Server 2016 will use both the data in the column store that I'm showing you by purple bars, as well as the data sitting in the hot portion to give you the real-time operational analytics. The key benefit is that you can do this without making any changes to your transactional application. And again, like before, there is no ETL, there is no separate data warehouse, just like disk-based tables. So these two types of database configurations where you have disk-based tables or memory-optimized tables, now you can do real-time operational analytics to deliver analytics in real time to your business so that they can make a decision for their business advantage. Now let's look at a quick demo on how real-time operational analytics can be done on both disk-based tables and memory-optimized tables. I'm going to show you first a non-cluster column store index on a disk-based table. So I have this database NCCI. I'm going to use that. And for this demo, I had pre-created the table, which was T column store table. It is a simple row store table with 4 columns, and I have a cluster index on column account key. And what I did was, after I created the table, I inserted 2 million rows into this table, which I show here in this loop. This is the loop where I'm inserting 2 million rows. And after that, I just created a non-cluster column store index. And notice, this is a simple DDL statement to create a non-cluster column store index. And that's all you need to do for your application to make it enabled for real-time operational analytics. After I created the index, I also inserted another million rows into this table. And the reason I did that, I wanted to show you the data that is compressed after column store was created and the new data that came in after the index, all right? So far, I have inserted 3 million rows. If I do a count star on this table, and you see I have 3 million rows. Now, if I want to show you how the data is organized for the non-cluster column store index, what you will see is that 2 million rows, this is 2 million rows that are compressed, and the new million rows that I added, they are sitting in the Delta store. This is where I can do my DML operations in a cheaper way. Now let me insert another 10,000 rows. And what I want to show you that these rows that I'm inserting are going to land in the Delta store. And if I look at my row groups again, here, you see that now I have 1 million in 10,000 rows. Okay. Now let's say you have created this index and now you want to do some analytics. You're running analytics queries on your transactional workload. And let me clean the buffers. And I'm going to enable the query plan to show you what's going on behind the scene. So all I'm doing is simple analytics query. So I'm saying select average from this table and let me run that. And what you will find that the query went through 3 million and 10,000 rows very quickly. And if you look at the query plan, it shows it is choosing column store. That means SQL Server Optimizer knows that this query will benefit using the non-cluster column store index. It picks that automatically. And if I look at the time it took for me to execute this query, you will see that the elapsed time for running this query was 0.186 seconds. And let's try to see what it would have been if the non-cluster column store index was not there. So what I'm going to do is I'm going to force using the cluster index that I have on this table and see what the performance looks like. So I'm going to run this query again by forcing the cluster index. If you look at the query plan, it is using now cluster index. It is not using the non-cluster column store index, right? And if I look at the time it took to execute this query, it is taking 0.484 seconds, which is approximately 4 times longer than it took with the traditional column store non-cluster index. So what I wanted to show you was that SQL Server automatically picks the column store index when needed, and it can deliver the analytics in a much more performant way. Now let me try the same thing with the memory optimized tables. So I have set up, like I did before, a table with memory optimized. So I'm going to use this database. And what you see is a table which is T column store HK, which is a memory optimized table. And I created the table. It has one primary key using a range index. That table was created. And then what I did was I created a column store index on that table, just like I did for the disk-based tables. And then I inserted into this table 5 million rows. Okay, this is like showing 5 million rows got inserted. So basically what you have now in this table, you have memory optimized table with column store, and you have 5 million rows sitting on it, right? If I do a column count star on this table, you see I get 5 million rows. Now, if I look at the row groups, remember this is a column store index on memory optimized table. What you see is that I have all the rows are compressed in this case, and there is nothing sitting in the hot portion that I was showing you for my in-memory table, okay? Now I'm going to start with statistics time on just to see how long it takes to run the queries. And then I'm going to run a very similar query that I ran with disk-based tables, and I'm going to make the query plan on here, and I'm going to run it. You notice it came back really, really fast, even though it had 5 million rows. Previously, we had 3 million rows for disk-based tables. And if I look at the query plan, again, like disk-based tables, SQL Server 2016 chose column store index automatically because it knows aggregate queries or analytics queries will benefit using column store. And if I look at the time it took to execute the query is literally 0.056 seconds. That's the time it took. Okay. Now let me run the same query by forcing an index that is not a column store index. So here I'm going to force that and I'm going to run the query. You see it took longer to run the query. And if I look at the execution plan, here I'm using the index that is not column store index because I forced it. And if I look at the time it took, notice it took 1.1 second compared to 0.059 seconds before. So what it shows is that the column store index can give you dramatic performance for analytics. And you can do that, as I was talking in the presentation, without impacting your transactional workload in a big way, because you can use configuration options available by keeping rows into the Delta store for disk-based tables, or by keeping the rows that are hot longer in your in-memory table before they are migrated to the column store. So by doing these things, you are able to do the transactional workload without changes while get the analytics performance and speeding up the performance of your analytics queries by many folds. Setting up real-time operational analytics in SQL Server 2016 is as easy as creating an index on an existing transactional table. And you could do that for disk-based tables as well as memory optimized tables. And here are some links to get you more information. And I encourage you to try this technology and see how it can benefit your business. In summary, the real-time operational analytics in SQL Server 2016 enables businesses to get a real-time insight on their transactional workload And they can do that on top of minimizing the cost of ETL as well as separate deployment. Thank you.